So 4.2 is about proportional relationships, and that's one of the big topics for seventh grade. And so that is what we're talking about. And so it's a special relationship between two quantities in particular. And so with proportional relationships, that's what we're talking about right now. Some also call them ratios, although it really just depends on how we're looking at this. So 4.2.1 says recognizing proportional relationships. Grocery stores often advertise special prices for fruits and vegetables that are in season. You may see a sign that says special today, buy 2 pounds of apples for $1.29. How would you use that information to predict how much you would need to pay if you wanted to buy 6 pounds of apples? Or just 1 pound of apples? The way that the cost of apples grows and shrinks allows you to use a variety of different strategies to predict and estimate prices for the different amounts of apples. In this section, you're going to explore different growths or different kinds of growth patterns, You will also use those patterns to develop specific strategies for making predictions and deciding if answers are reasonable. So we're going to ask these questions. How are the entries in the table related? So we definitely have a table. How can I double the values? What patterns can I see in a graph? So again, I have graph right here as well. So we have tables and graphs. So we're starting not with 4-21, although this does set us up for what we're going to do in 4-23. So it says college fund. 5 years ago, Gustavo's grandmother put some money into a college savings account for him on his birthday. The account pays simple interest, and now after 5 years, the account is worth $500. Gustavo predicts if he does not deposit or withdraw any money, then the account balance will be $1,000 5 years from now. So again, he's got this account that his grandma set up for him for college. After 5 years, he has $500. He thinks that if he leaves it alone, so a deposit means putting money in, withdrawal means pulling money out, taking money out of that account. If he just leaves it alone, the account balance is going to be $1,000 in another 5 years. Okay? So one of the questions I asked in class is, do you agree with Gustavo's reasoning? And some students said yes. Some students said no. But Gustavo really made his prediction because in 5 years he has $500. So if he doubles that time, so in 10 years, he thinks he's also going to double his money. So on 422, it says last week, Gustavo got his bank statement in the mail. He was surprised to see a graph that showed although his balance was growing at a steady rate, the bank predicted that in 5 years his account would only be worth $600. What's going on? He wondered, why isn't my money growing the way that it would? And so this one here has you predicting why his account might be growing differently than what he expected. Okay? But we're actually starting on 423. So again, we're using what was above, but we're now looking at it a little closer. So Gustavo decided to look more carefully at his account balances for the next few years to see if the bank's prediction might be a mistake. He put together a table below. So he has the time since the original deposit in years, and then the bank balance in dollars. So after 2 years, he had $440. In 3 years, $460. In 4 years, he had $480, and in 5 years, he had $500. So Alpha asks, how has Gustavo's bank balance been growing? So how has it been growing? So hopefully you saw the pattern. And so for this one right here, so the account has been growing by $20 per year. So, and again, we see that right here in the table. So to go from 2 to 3 years is 1 year. So $20 is from 440 to 460. So again, as we see that. Does Gustavo's money seem to be doubling as the years doubles? I think I better save this one for a different video.